Hello everyone, welcome to today's lecture. In this lecture, we are going to discuss about logical design of IoT. So, logical design of IoT system refers to an abstract representation of the entities and processes without going into a low-level specific of implementation. So, in the logical design of IoT, there are mainly three important terms, which is IoT functional blocks, IoT communication models, and IoT communication APIs. So in our previous video, we have discussed about the physical design of IoT. In the physical design of IoT, we are using that concept to design the physical structure of IoT application. But the internal working, structure, that is defined with the help of logical design of IoT. So let's start with the IoT functional blocks. So the IoT system consists of numbers of functional blocks that provides the systems the capability for identification or a sensing, actuating, or the communication or the management. So for that, the different functional blocks are available. The first is device. We all know that without device, IoT application is nothing. So the device is an IoT system which consists of devices that provides a sensing, actuating, monitoring and control functions. So for these types of functionality, we require a device. That is one functional block. The next is a communication. If we are using the devices, then the communication between that device will be, the communication between that device is required. So it handles the communication of the IoT system. So this is the second functional block. The third is services. So services for device monitoring, device control service, device publishing service for the device discovery. So these are the services provided by the IoT application. So this is one functional block. Next is a management. We require a management. So this function, we are providing different services, but the management of that all services will require. So this block provides the various functions to govern the IoT systems. The next is a security. So this block secures the IoT system and provides functions such as authentication, authorization, message and content integrity and data security. If we are publishing a IoT application, so at that time security is a major part. Without a security, we can't publish any IoT application. So the security is a major important block that is provided by the IoT. So we need to design the security based on your application. Next is the application. So this is an interface that the user can use to control and monitor various aspects of IoT system. Application also allows user to view the system status and view or analyze the process data. So the application, that is a user face, and we have to provide a user interface to the user. So that is provided by the application functional blocks. So we can say that the functional blocks means the services, or we can say that the functionality provided by the IoT application. So this is the block diagram for the functional block of IoT, which provides these different blocks like management, device, security, services, communication and application. The second important term is the IoT communication models. Now we design our application, but how the devices that are connected in the IoT application will communicate. So that is one question. So for that, different models for communication is available. The first is a request response model. So in the request response model, first client sends the request to the server. Now server receives that request from client and it processes that request and decode that request, and after that, if client requires some service, at that time server communicate with resources, and from that it fetches the required data as per client request, and server creates one response, and that response will be given to the client. And how this communication will happen into the request response model. So here client only can ask the question to the server, or we can say that client can request to the server, but server can't request to the client. The work for the server is only to provide response to the client. So that is the request response communication model. Next is a publish subscribe communication model. So in the publish subscribe communication model, that involves publishers, brokers and consumers. Here there are three users. The first is the publisher, which publish the content, which provides the content. Next is a broker. So broker accept the data, and the last is a subscriber. So subscriber consumes that data from the broker. So let's understand this with one example. Suppose in our TV, the publisher provides all the content of TV channels will available in our broker. Yes, so broker has all the data. But suppose in the Tata Sky, I have subscribed or the news channel only. So at that time I can only view the news channels. Another subscriber, suppose I subscribe the kids channel. At that time I can watch the kids channel. Okay, I can't watch all the channels at a time. If you subscribe all the channels, at that time only you can view that content. Otherwise you can't. So this is the publish subscriber model, that publisher publish the data that is given to the broker. Now from broker, subscriber will subscribe based on the requirement and they can access the data. So this is the publish subscribe model. The next is a push pull model. So in the push pull model, publisher sends the message into the queue. So here mainly there are two users, publisher and consumer. Here broker is not available. In the push pull model, publisher sends the message in the queue. So this is a queue. So publisher sends a message to the queue, and consumer, so we can say this process like publisher pushed a message into the queue. So this is the push operation, and after that consumer will pull the message from queue. So the push and pull will be continuous process. Here the second consumer is there. So publisher sends the message into the queue, and from this queue consumer too will pull the messages or the pull the services. So this is how the push pull model works. And the last is the exclusive pair model. So in the exclusive pair model is a bidirectional fully duplex communication model. So what happened? This is a client and this is a server. So client sends a request for the connection setup. Now server accepts the request. Now in the exclusive pair model, this is a full duplex model, means both can communicate. Like client also send a request to the server and server also can send a request to the client. So they both can simultaneously communicate with each other. So this is why it is called the exclusive pair model. Okay, in the request response model, the difference is in the request response model, client only can send a request to the server, but server can't. But in the exclusive pair model, server and client both can do this. So this is called the bidirectional model. So these are the communication. So these are the IoT communication models. The third important term, which is a communication APIs. So generally we use the two APIs for the communication, which is a REST based communication API and the WebSocket based communication APIs. So the first is a REST based communication APIs. So REST is a architectural principles by which you can design a web services, the web APIs that focus on systems resource and how resource states are addressed and transferred. REST API that follow the request response communication model, and REST architectural constraints apply to the component, connectors and data elements within a distributed hypermedia system. So in the REST based system, we can say that it is a stateless system. So every time if you want to ask something to the server, at that time you need a connection. Every time you need to make a connection, and after that you can request some data. It is a stateless, and the server can't store the states. And also the REST based communication API use the request response model. So only consumer, means only client can send a request to the server, and server will provide a response to the client, but server can't request to the client because it is a it uses the request response model, and the REST based communication API is a stateless. So that's why every time when we make a request to the server, we require a TCP connection. So every time we have to make the TCP connection, we have to establish the TCP connection, then we'll communicate with each other, then we'll close the TCP connection. Again, if you want something from server, we'll establish the TCP connection and then we'll communicate. So this is the process for the REST based communication API. Next is a WebSocket based communication API. So WebSocket based APIs are the bidirectional full duplex. So we can say that it uses the exclusive pair communication model. So this is a full duplex or the bidirectional model. So client and server both can communicate with each other simultaneously. Unlike request response models, such REST and WebSocket API allows a full duplex communication and do not require a new connection to be set up for each message to be sent. So this is a full duplex. It uses the full duplex, and we can say that WebSocket based API is a stateful. So we do not need to establish the new TCP connection every time when we want to communicate. So first time if we made the TCP connection, so after that we can anytime we can communicate with the server. So here we require only a single TCP connection. So that is the IoT communication APIs. So this is all about the logical design of IoT. So that's it. Thank you so much.